Hello friends, if you don't know me, my name is Aksh and I will be teaching you class 7 science and maths and talking about my recent achievements. I've got All India rank 18 in Prince Olympiad 2024 and All India rank 26 in ANSAT 2024. So today we are going to start a new chapter, which is chapter number 9 of science, which is motion and time. So let's start. Let me underline the heading, chapter number 9, motion and time. The object moving along the straight line is called rectilinear or the straight line motion. Motion along a circle is called circular motion. When an object repeats its motion after a fixed interval of time, it is said to be in periodic motion. So these are the three types of motion which we are going to use in class 7th, motion and time. I know there are many more motions which you learned in class 6 also, like the random motion, but right now we will not be using it in class 7, and these three motions are important. And again I am saying that these motion are rectilinear or straight line motion, means when the object is moving along a straight line. You can say, example you can say is a horse pulling a cart on a straight road. Okay, motion around a circle is called circular motion. Yes, like you can say athletes running on a circular ground. Yes, or you can say children playing on a merry-go-round. When an object repeats its motion after a fixed interval of time, it is said to be in periodic motion, or you can say oscillatory motion too, like simple pendulum, as we talked. We have not talked till now, but we will talk, and one example is simple pendulum. Now let's talk about speed. Speed is a distance covered by an object in unit times. So speed is a distance covered by an object in unit times. This is the best definition you can learn. And some formulae. These are the formulae. We don't say formulas in English. We say it formulae. Okay. So first, S is equals to d divided by t, which means speed is equals to distance divided by time. Next, distance is equals to speed multiplied by time, which is distance is equals to speed multiplied by time. T is equals to d divided by s. It is time is equals to distance divided by speed. For speed we use s, distance d, time t. Okay, the SI unit of distance is meters, which is a small m. SI unit of time is equals to seconds, small s. SI unit of speed is meter per second, which is m per second. Here it is not divide, it is per. Okay. The full form of SI is Système International des Unités in French. It is a set of measurement accepted by the whole world. Okay, so when there was a need of measurement, so whole world was using different accurate or inaccurate measurements. So whole world accepted one set of measurement which was called SI. Okay, and its full form in French. We usually say this in French, which is Système International des Unités. Okay. Some other systems of measurement that were not accepted. Some other systems were also there, but they were not accepted. Like the FPS system, which was foot, pound, second system. Okay. CGS system, which was centimeter, gram, second system. MKS system, which was most, means it was same as SI, but it was not accepted. SI was accepted. MKS is same as SI, like meter, kilogram and second system. Okay. So we can mark a star here because it is same as SI. It is same as SI. Now coming on to the time chart. So 60 seconds is equals to 1 minute. 60 minutes is equals to 1 hour. 24 hours is equals to 1 day. 365 or 366 days is equals to 1 year. 10 years is equals to 1 decade. 10 decades, which is 100 years, is equals to 1 century. And 10 centuries, which is 1000 years, is equals to 1 millennium. Okay. In older days, let's talk about older days, how they measured seasons, how they measured time, month or years. Okay. So time, how they measure time. So time was measured by looking at the sun's position. So they made many sundials. Okay. They made sundials at one place is Jantar Mantar. Okay, Jantar Mantar, where you can see that. So they used to measure the time looking at the sun's position. Okay, but the sundials and the Jantar Mantars were not used when the sun sets. Means in the night and the after the sunset, they cannot use these to measure the time. Okay. Month was measured by one new moon to the next or one full moon to the next. Like as we know, new moon and full moon comes once in a month. So they indicate a month is over by saying that today is a new moon night, or you can say one day is a full moon night, and they will wait till the next new moon night if they are following the new moon, and they will wait till the next month full moon night if they are following the full moon. And year was measured by one revolution of earth around the sun, or by mainly you can say by the changing of seasons. Like you can say they would have known that this is very hot, this is one of the hottest season, so they could have taken that and wait for the next year when the season will come back. They can take any season, whether it can be winter or spring or anything. Okay, not spring but mainly monsoon you can say. Okay, so they will wait for the another season that will be the same, so they can indicate like this that year is over. Now talking about uniform and the non-uniform motion. Uniform motion. When an object moves along a straight line with a constant speed is said to be in uniform motion. Okay, and equal distance is covered in equal interval of time. Non-uniform motion. When an object moves along a straight line and sometimes not, and keeps changing its motion is said to be in uniform motion. Non-uniform motion means unequal distance is covered in equal interval of time. Now you will say, how, when there is unequal distance, why in equal interval of time? Like, okay, let me give you an example. This is one pole. This is one pole. This is one pole. Now one car is starting from here and reaching here in 5 minutes. Okay, 5 minutes, and traveling 5 kilometer only. The poles are at 5 kilometer each. Okay, and again when it reaches to here, it again takes 5 minutes to go to the another pole. So this is a uniform motion. Yes. Now if I talk about the non-uniform motion, so if I say this is going in 6 minutes, and here due to jam it is moving in 10 minutes. So unequal distance means timing is changed, but an equal interval of time. Now you cannot change the time. You cannot change the interval of time. This to here will be equal interval and this to here will be equal interval. You cannot change the time. Yes. That's why unequal distance is covered in equal interval of time. Now talking about a famous scientist named Galileo Galilei. Named Galileo Galilei. And we are right now studying the history of just wait, I should take a lighter color. Why it's not working here? I'll leave it. History of simple pendulum. So let's talk about simple pendulum and its history first. There was a famous scientist named Galileo Galilei. Once he was sitting in a church. So he was sitting in a church. He saw a lamp hanging on the ceiling and moving to and fro. Means he was sitting in the church and he saw a lamp just on the ceiling and it was hanging and moving like to and fro. Like this, okay? So he observed time it took for one oscillation was equal to constant number of pulses each time. So we have already talked about pulse rate and pulses. So he was just taking his wrist and counting the number of pulses it took for the one oscillation. And he observed that it took for one oscillation was equal to a constant number of pulses each time. This led him to experiment with pendulum. Now talking about a simple pendulum. Very simply talking about a simple pendulum. Let's take this color. A simple pendulum consists of a metallic ball called bob hung on a rigid stand by a thread. So here one stand is there, a rigid stand, and then a thread is there hung on the stand, and attached to the thread there is one metallic ball. Remember it is metallic. It is a metallic ball and it is called bob. It is called bob. Okay. So mean position is the position of the pendulum when it is at rest. So here the pendulum is at mean position. See, right now it is not moving, so right now it is in mean position. When bob is taken to one side and released, it moves to When bob is taken to one side and released, it moves to and fro. When this bob, this is a bob, yes, and when this bob is taken here, yes, and left, so it will first go here, then here, like this it will do oscillations, and it is moving to and fro. So this is called periodic or oscillatory motion. when the bob moves from the mean position to its one extreme position, then to its another extreme position, and then back to its mean position, is called an oscillation. So when oscillation is like here is the mean position. I am moving like this. Mean position moved. So from its mean position it goes to here, then to this extreme, then back to its mean position. This is called one oscillation. And here's a diagram. So see, this is a stand, this is a stand, this is thread, and this is bob, and it's in mean position. So when this bob is pushed from its mean position, it will first go here or here. First, according to this diagram, it will go here to its one extreme position. This is an extreme position. Then it will go from here to here, again to its another extreme position, and then it will go back to its mean position. Yes? And this is one oscillation, and this is one oscillation. Today was a part 1 of this chapter. Tomorrow will be the part 2. Part 1 done. Part 2 tomorrow. Till then, thanks. And if you don't know my channel's name, it is okay. So I hope this was clear. And one more example, if I give you, let this be the main position as A, this be B, and this be C. So first the position will be the movement to and fro, periodic movement, or you can say the oscillatory movement will be A to B, then B to C, and then back to A. So this will be the motion of the pendulum, if I name. And sometimes in the picture, in the exams, in the competitive exams, it can come like this is the mean position. Instead of this, it is not there that this will only be the mean position. So this can also be the mean position. Any of the extreme position can be made the mean position, and then it will move from here and here. So you have to do like that. Okay. Thank you. I hope you understand everything. Thank you. And if you don't know my channel's name, it is Study with Aksh. Okay. Bye.